Yeah, so today's lesson, we're going to look at solving with right triangles. Solving with right triangles. I think we've looked at all the trig ratios, not all the trig ratio per se, but we look at the three basic trig ratio, the tangent, the cosine, and then the sine, and then how to solve with them. And then we talk of right triangle, then we talk of the Pythagoras theorem. So solving with right triangles in this lesson, it's just an application of everything that you've learned on Pythagoras theorem and then trig ratios. So there is not any new concept. It's the same thing that you know already. So all that you need to know is to remember your basic trig ratio and then your Pythagoras theorem. At times you may need them and apply them in this topic. So this topic is just going to be questions and answers, a whole lot of questions, and then answers, then you apply them. So like you could see, I just made this one as a sample for you to see. Just made this as a sample for you to see that, like, if you have a house here, you have um, a tower here, and then you want to maybe calculate the angle over here, that's the angle of elevation, or you want to calculate the angle of depression, you know that this forms a right triangle. So with that, you can use your trig ratios and the rest. So before we move on with some sample, let's revise ourselves with some of the things that you've learned already. So first of all, let's look at the Pythagoras theorem that we talk of. So we said if this is A, this is B, and this is C, Pythagoras theorem say that C squared is equal to A squared plus B squared. So this is one thing that you need to remember. And then for the trig ratios too that we talk of, for the trig ratios, we had, just put this triangle here, put it on focus. Okay, so we have this triangle. Oh, sorry, let me put a 90 degrees here, I forgot. Yeah. So with the same thing that we talk of, let's say this is A, let me see, ABC. And then line AB is A, line AC is B, and then line BC is C. C. So we have the trig ratios that we talk of. We have the tangent, we have tan, we have sine, and then we have cos. We said that tan is equal to, and then we remember the acronym that we use. So SOHCAHTOA. So this is tan opposite over adjacent. So tan is equal to opposite divided by adjacent. Sine is opposite hypotenuse. So sine is equal to opposite over hypotenuse. And then cos, adjacent over hypotenuse. So cos is equal to adjacent over hypotenuse. So these are the trig ratio, the basic trig ratio that we've talked of, and these are the things that you need to remember. These are the things that you need to remember. So with this, we need to identify our opposite, our adjacent, our hypotenuse. And so let me put in another triangle, and then let's do that with it. So if you have this triangle, Again, this is our 90. That's our 90. So let's identify our opposite, our adjacent, our hypotenuse. And then let's label A, B, C. A, B, C. We said that our hypotenuse is always opposite to the 90-degree angle. So this is the 90-degree, and then the line opposite. So line AB will be our hypotenuse. So our hypotenuse is going to be here, line AB. We talk of opposite and adjacent that they depend on the angle. They depend on the angle. So if you are talking of angle A, if you are talking of angle A over here, then this is going to be our opposite because the line BC is opposite to angle A, and then the line AC will be our adjacent because angle AC makes touches the angle A touches the line AC is from the AC. It's from the AC. But if you are talking of angle B here, if you are talking of angle B here, then here becomes our opposite, and then here becomes our adjacent. So know the difference, that hypotenuse always stays the same. Hypotenuse always stays the same. Opposite and adjacent will depend on the angle in consideration. So the angle you are considering in your question will determine which side of the right triangle is going to be your opposite, and then which side is going to be your adjacent. So that is what you need to know. And these are things that you've done already, but we just revisiting it because solving triangle with triangles it's not anything new. It's just the application of everything that we've learned already. Application of everything that we've learned already. So let me label our hypotenuse here. Let's say our hypotenuse is 5, and then let's say our AC, which could be adjacent, which could be opposite depending on the angle. Let's say it is 3. And then let's say our BC, which could be opposite, which could be adjacent depending on the angle. Let's say it is 4. So our with our ratios here, what we discussed over here, then I can see that sine A is equal to, we said sine is SOHP, which is opposite over hypotenuse. So if that is opposite over hypotenuse, if we come to our triangle, this is sine A, this is A, this is A, and our opposite is 4. Our opposite is 4. So we're going to get 4 over hypotenuse, which is 5. I don't know, it seems my pen is very faint. Let me see if I can make it bold. So our sine will be opposite, which is 4, over the hypotenuse, which is 5. So I just look at identify my opposite and then identify my hypotenuse. So if I want to find sine B, so let's say sine B is the same thing. Sine is opposite over hypotenuse. But if you come to your triangle, here, because we are talking of angle B, our opposite is going to be 3. And then our hypotenuse stays the same thing, which is 5. Which is 5. So that is what you need to know I'm not going to go over the rest because it is something that we did already. You can go back to the previous videos on each of these ratios and then look at it and work more on it. So one more thing that we need to review or we need to look at is finding the angle. Finding the angle. So finding the angle. So what we saw that, let's say we have sine A is equal to opposite over hypotenuse. That is what we knew. But okay, let me just put a triangle there to help us. So I have to clean this one. This is my 90 degrees. Let's use the same number, 5, 3, 4. So let's say this is our triangle, and then we want to find the value of this angle, angle B. So I can use any of the ratios, any of them to do it because I have all the sizes. So I can use sine B is equal to opposite over hypotenuse, which is 4 over 5. 4 over 5. So if I want to find B, the angle B, so that's going to be B is equal to sine inverse of 4 over 5. Then you just put in your calculator to find the value for B. You just put it in your calculator to find your value for B, and then our B is going to give us 53 degrees. Our B will be 53 degrees, so angle B. So, and then you use it for all of them. We did this earlier, we discussed it, so it is something that you can go back and then look at it. So that is it. So now you know your B is 53. That's finding the ratio, the inverse of the ratio. That is what you use to get the angle, the value of the angle, the value of the angle, the value of the angle. So that is very, very important. One more thing that you need to know is this is just a revision. That is why it seems I'm rushing, but because we've done it already, that is why like I'm moving fast. So one more thing that you can look at. Okay, before I move on with the other thing, let's look at this one. So now you know that here is 53. You can use, you know that the sum of the three angles of a triangle is equal to 180. So you know here is 90, here is 53. So you can add 90 and 53, subtract from 180 to get this angle. Or you can still use trig ratio and find the inverse to get C. So if I want to get C angle C, I can choose to use, let's say, cos. I can choose to use cos. So cos C, you can choose to use any of the ratio and you see that you come up with the same answer. Cos C is equal to, cos is what? Adjacent over hypotenuse, so 4 over 5. So C is equal to cos inverse. C is equal to cos inverse of 4 over 5. Just put it in your calculator, cos inverse of 4 over 5, and then see what you get. And then that will give you 37 degrees. I just run it to the nearest whole number. So that will give you 37 degrees. So C is 37 degrees. Let's see. So if you have 90 plus 53 plus 37, and that will give us 180. degrees. So you see it works. And then you can try with all the different ratios and you see that you are going to get the same thing. So you can either use your sum of triangle equal to 180 to find, if you know one, you know the 90 already because it's a right triangle. So if you are able to find the other, you can use that to find the other, or you can still use the ratios to find the other. In most cases, yes, questions will not be specified like use the ratios, but if it is specified, maybe the teacher want to know your understanding of it and it is specified, you use that. So what I wanted to say again is like finding one of the sides. Let's say one side is missing. We're still using our 5, 3. So let's say this side is missing. A, B, C. This side is missing. So, and then you are asked to find this side. So if this side is missing, you have your, so you can choose any of the angle to work with to find this side. You can choose any of the angle to work with to find this side. So let's say we are working with angle A. Angle A. So because this is missing and this is opposite and this is hypotenuse, if you want to use sine, then that is what we will need, opposite and then hypotenuse. If you want to use cos, then we will need angle C, which will give us adjacent over hypotenuse. If you want to use tan, then we could use any of A or C because we have the opposite and then the adjacent. 3 will be depending on which one you are using. You can still get your S. So now since we have, let's use the hypotenuse and sine. So opposite and hypotenuse. So sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So if you have such thing, your angle will always be given to you. So we know that here is 53 based on what we did first. So you have your angle there in your question. So you're going to have sine 53 is equal to x over 5. So just your basic algebra, you multiply through by 5, you're going to get 5 sine 53 is equal to x. And then, so you just put it in your calculator, 5 sine 53, you just put them in the calculator, and then you're going to get x equal to 4. You're going to get x equal to 4. X equal to 4. So that is how you'll be able to find one missing part. How to find one missing part. One missing part. So, and then you can use any of them. And then in this case too, you can use the Pythagoras theorem that we spoke of to find this missing part, because we know that 5 squared is equal to 3 squared plus x squared. And then you can use that one to find it. So we're going to get 25 squared minus, sorry, 25, not 25 squared. 5 squared is 25, not 25 squared. Minus 3 squared, or let's say 25 equal to 9 plus, this is plus, it's nothing, plus x squared. So you group like term, and then you're going to get 16 is equal to x squared. 16 equal to x squared. If you find the square root of both sides, you get your x is equal to 4. Get your x is equal to 4. So this is how you be able to solve it triangles. This is how you'll be able to solve it triangle. Let's try with one example, and then let me see. Well, I'm actually late in recording this, so I think I'll bring more example later, but just go about this one and then just yeah, look at it. Try your own, just play with your own triangles, put some triangles down and then just play with it. I may put some questions down later that you may look at it. So I think we have to end here. Thank you.